Lesson 87, more on systems of equations and functions. So remember that these kind of examples, when we have the RETE, what that is representing is distance. Because if I multiply the rate or the speed times the time, I get distance. The rate of Esteban times the time of Esteban equals the rate of William times the time of William. And what I'm actually saying is that they travel the same distance. Both of the distances are the same. Now, how can that be? Well, if I run at a certain speed for a certain amount of time, and then someone else goes faster, they'll cover the same distance, but in a shorter amount of time. And that's how they are able to be equal to each other. So that is the main equation. And then they give us extra information here. They said that the rate of Esteban is 200. Then they say that the rate of William is 250 and that the times together is 9. So what I have to do is substitute each of these values into the main equation. So RE is 200 and then TE that we don't know. And then RW is 250 and then TW that we don't know. And again, remember, we cannot have two different variables, so we're going to write one of the variables in terms of the other one. So I'll leave TW by itself, and I'll pass the TE to subtract. Now we're ready to substitute in the main equation. So I'm going to leave the 200 TE, and then the 250 is going to multiply, remember, with a parenthesis because you're going to multiply times a binomial. So it's 250 times 9 minus TE, which is the value of TW. Now that we have the same variable on both sides, we can simplify this. We have 200 TE equals 250 times 9 is 2,250. And then 250 times negative TE is negative 250 TE. Then I'll pass that negative to the other side to add 450 TE equals 2,250. And if we divide that, then we get that TE equals 5 hours. Once we find that time, then we can go to the other one that is in terms of the TE or the time of Esteban, and then just substitute and find the answer. So 9 minus 5 is 4. And that's the answer. This next example is very similar. You can try to do it by yourself and then check the answer. Notice that the only difference is the main equation looks a little bit different, but it's the same thing. So what we're saying in this case, though, is that the first distance plus the second distance equals 360. So, for example, the distance of the first car plus the distance of the second car is 360. Are they the same distance? No, but together they add up 360. So we have to do the same, use that main equation as our base, and then substitute the values that are given. Now again, remember, we cannot have two different variables, so T2, we leave it alone, and we pass the T1 that is adding to subtract. And again, now we can substitute that. Instead of T2, we're going to write a parenthesis with the 10 minus T1. And now that we have the same variable, we can do distributive property to solve. Remember, we want like terms, so 30 minus 40 is 10 T1, and then the 400 goes to subtract, so it's 360 minus 400, which is negative 40. And if we divide negative 40 divided by negative 10, the answer is positive 4, and that would be the first time. Then to find T2, we just have to subtract 10 minus 4, which we found is T1, and the answer is 6 hours. And that's it. That is our answer. Very simple. Make sure that you practice this so that you are clear on what you're doing. The second part of the lesson is really fun and easy. And all you have to do is a test, in this case a vertical line test, to check if these drawings, if these graphs represent or not functions. And all you have to do is draw a vertical line or different vertical lines to make sure that they always touch only one time. So if they intersect the drawing, the graph, only one time, it is a function. But if it intersects two or more, it's not a function. For example, if I draw a vertical line there, it touches only one time. If I draw it here, it touches one time. If I draw here or here or here, it always touches only one time. So that says that that is a function. Now in the other one, for example, if I pass the line here, that touches only one, so that's good. But what happens if I pass it here? It touches two. Or what happens if I pass it here? It touches 1, 2, 3, 4. So in this case, where it's touching two or more is not a function. Let's look at this other one. In this one, if I pass it, there is 1, 1, 1, 1, 1. In all of them is 1. So this one is a function. Now again, in this other one, notice that if I pass it here, we're good. It touches 1. But if I pass it here or any other place after that, it's going to touch two places, so it's not a function. Then we have a parabola. Parabolas are functions. Notice that if I pass the line, it touches only one. Now you might say, but if I pass it here, it touches two. No, it may seem that it's touching several, but it's only touching one. It's that our drawings are kind of weird, but it is touching only one point. So this one is a function as well. Now the last example is interesting because if you pass here, all of this is just one time, so that's a function. And even here, if you keep going, it's a function. And here, it's a function. But what happens right here? Well, it touches 1 and 2. And even though everywhere else it works, just because that one point where we have two intersections, it's not a function. And that's it. That is the vertical line test. Pretty easy. All right, if you have any questions, let me know. I'll see you in the next video.